So for this first part of the review, we're asked to find P and Q. So if you notice here, it's in factored form, and it crosses at 2 and negative half. So we know that this is y equals, there's some a value. If it's crosses at negative half, it has to be positive half and x minus 2. So we know that's the equation. So it asks, what are the values of P and Q? Well, it would just be where they cross, so negative half and 2. Now the next thing says the function has a minimum value at point C. Find the x coordinate. Well, that's your vertex. Well, we know our vertex is halfway in between these two. So we can just say, well, to find our vertex, negative half plus 2, halfway between there. So 1.5 divided by 2, and it's 0.75. And so you'll notice here it just says find the x coordinate. We don't have enough information to find the y. So the second one here, it says express x squared minus 6x plus 14 in the form x minus h squared plus k, where h and k are to be determined. Alright, so basically this is saying find the vertex. So x coordinate is the opposite of b over 2 times our a value. So that's going to be 3. And so we can plug it in to find our y coordinate. So we have 3 squared. 6 times 3 plus 14. So let's see, that's 9 minus 18, so negative 9 plus 14. So y is 5. So our h value would be 3 and our y value would be 5. Hence, write down the coordinates of the vertex. So our coordinates would be 3 and 5. So the last one on this page, we're given a diagram, x squared plus px plus q, and the graph cuts the x-axis at negative 2 and 3. So find the values of p and q. So we know our a value is 1 because of the x squared, and so we know our equation would be x plus 2 and x minus 3. So if we multiply this out, we have, let's see, x squared minus 3x plus 2x minus 6. So y equals x squared minus x minus 6. So if we line that up here, x squared minus x minus 6, our p value would be negative 1. Our q value would be negative 6. So if we flip to this back page here, number 4, we're asked to find this first one. Consider the function. Here's f. And this is just a fancy way of saying f of x equals 4 times x minus 1. And g of x equals 6 minus x over 2. So the first thing, find g negative 1. Well, that means the inverse. So I'm going to switch the x and y. So we have x equals 6 minus y divided by 2. Well, now we have to solve for y. So times 2 times 2. So now we have 2x equals 6 minus y. Subtract 6. So we have 2x minus 6 equals negative y. Divide by negative 1. So we would have negative 2x plus 6 equals, see if I can fit this on here, our inverse. So solve the equation, the next one, f of g inverse, so the composition of f of g inverse of x equals 4. So I'm going to go to the f function, 4, but I'm going to replace the x with our inverse, so negative 2x plus 6. Well, then we have minus 1 equals 4. So let's see, so this is 4 times negative 2x plus 5 equals 4. Divide by 4, negative 2x plus 5 equals 1. Minus 5, negative 2x equals negative 4, so x would equal 2. So number 5 here, consider the function 2x squared minus 8x plus 5. Express in the form in vertex form, basically, is all it's saying there. So we got to write this in vertex form. So we have to find the vertex. So the opposite of b over 2a. So that would be 8 over 2 times 2. So 8 over 4 is 2. If we plug that in, 2 times 2 squared minus 8 times 2 plus 5. So 2 squared is 4 times 2 is 8. So 8 minus 16 is negative 8 plus 5 is negative 3. So if we plug this in, y equals a is 2, x minus 2 squared minus 3. Find the minimum value. Well, our minimum would just be our vertex, so that would be 2, negative 3. Number 6 here, the diagram shows part of the curve in vertex form. The vertex is 3, 1. Write down the values of h and k. Well, h would be 3, k would be 1. The point 5, 9 is on the graph. Show that a is equal to 2. Well, we can do that. So y equals a, our vertex, so we know it's x minus 3 squared plus 1. And we can plug in that point 5, 9. So 9 equals a, 5 minus 3 squared plus 1. 5 minus 3 is 2. 2 squared is 4. So we have 4a plus 1. Minus 1, 8 equals 4a, so we just showed that a has to be 2. Now we're asked to show that our equation can be written and it's written in standard form. So we know it's 2x minus 3 squared plus 1. So we have to multiply this out. So 2x minus 3, x minus 3 plus 1. So this is 2x squared minus 3x minus 3x plus 9 plus 1. Jeez, there's not enough room on here. So we have y equals 2x squared minus 6x plus 9 plus 1. So if we distribute the 2x squared minus 12x plus 18 plus 1, which equals what we wanted, 2x squared minus 12x plus 19. So this next one, number 7, consider f of x equals 2kx squared minus 4kx plus 1. Show that it has 2 equal roots. So 2 equal roots means it hits the x-axis once. So we know that b squared minus 4ac has to equal 0. So if we substitute these values in, so negative 4k squared minus 4 times a times c has to equal 0. So let's see, so this would be 16k squared minus 8k equals 0. So if we factor in 8k out, we'd have 8k times 2 minus, let's see, so that would be 2k minus 1 equals 0. So k equals 0, 8k equals 0, or 2k minus 1 equals 0. So k equals 0, or this one would be k equals half. All right. So this next one, the line y equals p intersects the graph of f. Find all possible values of p. We know about this quadratic. We know it has 2 real roots. So, and we know k can't be 0. So I guess we know k equals 1/2. So if we substitute that in there, we know our equation k is half. So 2 times half x squared minus 4 times half x plus 1. So we know that this is x squared minus 2x plus 1. So this factors into x minus 1, x minus 1. So we know it crosses at 1. So we know it looks something like that. So the line y equals p. So we know the line y equals p, it's a horizontal line. If it intersects the graph, well, what does it have to be? Well, our parabola is positive, so p would just have to be greater than or equal to 0 for it to cross, because if it was less than 0, it would not cross it. All right, number 8. Part of the graph of the function is given below. We're given the x-intercepts and the vertex. Write down the values of m and p. So let's see, what do we know? This is y equals, they have a d, but I'm going to put an a, x minus 1, and this is x minus 5. So that's what we know. We don't know our x value, but we know that our vertex is at 2. Well, if we know our height is at 2, it's got to be right in the middle of these, our x values. So let's see, what's 1 plus 5 divided by 2 is 3. So this is the coordinate 3, 2. So m would have to be 3, and p would have to be 2. Well, then we're asked to find d. So I'm going to take this equation here, d is really the same as a, and plug in our vertex of 3, 2. So our y value is 2 equals a, 3 minus 1 times 3 minus 5. So 2 equals a times 2 times negative 2. So 2 equals negative 4a. So a would be negative half, which is the same as our d spot. It's like crossing this out and just saying that that's the a. So number 9 here. Find an expression for h of g of x. So h of g of x, so that would be 5. I'm going to replace the x there with 3x minus 2 divided by, we have our x again, so 3x minus 2 minus 4. So if we simplify this, we have 15x minus 10 over 3x minus 6. Solve the equation, when does h of g of x equals 0? So when does 15x minus 10 over 3x minus 6 equals 0? Well, if we multiply by 3x minus 6 times 3x minus 6, so when does 15x minus 10 equals 0? So that would be when x is equal to 10/15.